What's up YouTube? Welcome back to the channel. Today I'll be giving you guys a walkthrough of the roller coaster world that I've crafted in MassiveLoop. For those unfamiliar with MassiveLoop, it's a metaverse platform that empowers digital creators to create their very own metaverse. Its server system is similar to Discord, and it provides creators an opportunity to monetize on their work through a Patreon-like system. MassiveLoop is also the sponsor of today's video. Now, in terms of the structure for the video, I'm going to first give you guys an overview about the RollerCoaster project, then show you guys the assets I used, and then talk a bit about the environment and the transitions between them. Then lastly, talk about the scripts that make it all function. Now, without further ado, let's dive into today's video. So, the name of the project is Nova Coaster. The coaster starts off on Earth near an island, then transitions into Earth's atmosphere, then into space, deep space, and then back to Earth's atmosphere. From there, it descends into the ocean and then returns to the starting point, which is the station on the ocean. If you guys would like to try this roller coaster experience, I'll be leaving a link below in the description to my MassiveLoop server called The Playground. From there, you can hop into the Nova Coaster world to give it a try. I utilized a combination of both paid and free assets for this project. For the actual coaster, I used the animated steel coaster asset from the assets store and the tracks and rails asset for building the roller coaster tracks. For the ground environment, I used a space station scene 3D model I found on free3d.com. The surrounding environment featuring the mountains and clouds was made using the Mountain Environment Dynamic Nature assets. And as for the skybox, I used a free skybox pack I found on the asset store. For the thermosphere, which is the layer of the Earth's atmosphere where satellites and the International Space Station orbit, I utilized the Sci-Fi Space Base asset along with one of the skyboxes from the free skybox collection I mentioned previously. For the deep space environment, I used a free asteroids pack alongside a moon model from the Earth, Mars, and the Moon asset pack. And I used a skybox from another free skybox asset pack called Earth and Planets. Lastly, for the ocean environment, I used the underwater animals pack and the glass underwater effects for the surrounding environment and skybox. Now let's get into the actual project. The first thing I did was create 5 different environments. The ground environment where the coaster starts, the troposphere, which is where you can usually find planes, the thermosphere, which is the most outer layer in our ozone where the satellites and the International Space Station orbit, deep space for where the moon is, and lastly the ocean environment. Each environment has its own processing, post-processing and light source profiles, except the thermosphere because the coaster doesn't spend much time in this environment and there aren't many objects in this environment. One of the issues I ran into right at the beginning was the proper scaling for each environment and how to transition from one to another in a manner that made sense. For the transitions, I decided to use these sci-fi gates at certain parts of the ride for a more immersive transition. I didn't use the gate for the ocean transition because realistically speaking, transitioning from above to below water is instant. As for the scale of each environment, I found that creating the ground environment first helped, and then creating the coaster tracks right after kind of just paved the way. Using the tracks and rails asset, I was able to effortlessly create the tracks in the editor. Once I got to a certain distance off the ground from the first environment, I placed a transition gate to indicate the trigger for the transition to the next environment. The roller coaster requires 3 scripts to function properly: the spline segment script, the spline script, and the roller coaster script. All 3 of these scripts are written in Lua. First, let's talk about the spline segment script, which is the foundation for the movement. Splines are smooth curves used in graphics, computer graphics, animations, and game development to represent paths or motion. Specifically, the spline segment script is designed to work with the cubic Bezier spline. I'm not sure if I'm pronouncing that right, but it's called the cubic Bezier splines. We'll go with that. Which are defined by 4 control points. The calculate position function takes in the parameter t, which represents a normalized position along the spline. The t parameter can be any number between 0 and 1, and each segment on the spline is represented by 4 control points. This function calculates each segment of the spline corresponding to the given t value. Using the cubic Bezier formula, it creates a smooth curve between these control points. The local t value adjusted for the specific segment determines the exact position on that curve. The function then converts the position into a 3D coordinate and returns it, pinpointing the location on the spline that corresponds to the initial t value. The getControlPoints function gets all the control points that are children of the game object, which this script is attached to. It also sorts the control points in an order that is compatible with the cubic Bezier formula. In Bezier splines, the last control point of one segment typically becomes the first control point of the next segment. I'm going to display an indexing pattern on the screen for clarification. Next, we have the spline script. Overall, this script is designed to pre-calculate and store spline data for efficient runtime use. It samples the positions on the spline right at the start of the world and does so in batches for optimization purposes. It utilizes coroutines for performance optimization, allowing the game to continue running smoothly while the spline data is prepared in the background. Next, we have the RollerCoaster script. The script is like a central hub for the roller coaster movement. It handles the movement, rotation, and the coroutines required for the activation of transition effects. Lastly, we have the follower script. The script calculates the distance between the main coaster and the follower. It maintains a constant distance between them depending on the distance that I specify. After creating the scripts required for the roller coaster's movement, I developed a control point spawner that leverages the existing spline data from the tracks to spawn control points. Although this script isn't really essential for the coaster's functionality, it simplifies the process compared to manually placing the control points along the track. I implemented this feature in C# and added a green gizmo for better visualization of the spline in the editor. The gizmo only appears when the control points align with the specified indexing pattern I mentioned earlier during the explanation of the spline segment script. For managing the coaster's speed, I created a script that activates when the roller coaster passes through a trigger zone. The script adjusts the coaster's speed and changes the audio clip to match the coaster's current velocity. I then created a prefab based on the script and strategically placed multiple instances along specific points of the track. These instances serve to speed up or slow down the coaster, providing a more dynamic and thrilling experience. While developing the coaster logic, I encountered an issue where the roller coaster would unexpectedly change its orientation whenever it faced directly upwards or downwards at a 90-degree angle. To address this, I created a script named trigger enter and converted it into a prefab. This script essentially prevents the coaster from rotating upon activation. Although this solution served as more of a temporary patch than a permanent fix, it came with a limitation. It basically removed the possibility of the coaster performing loop-de-loops. So yeah, no loops. There are a total of 7 transitions in the project. Each transition changes the environment to the next while restoring the previous environment to its original state. It uses 2 scripts to accomplish this. The first script is the environment changer, which changes things like the skybox, fog, surrounding environment, as well as deactivating the previous roller coaster tracks while activating the next tracks for more immersion. The second script is the reset transform script, which stores all the transform of all child objects of an environment. The activation of each transition requires the player to pass through the trigger box. Each transition occurs locally, so the environment only changes for the player who passes through the trigger box. For the doors, I crafted a script with on-trigger enter and on-trigger exit functions. The door toggles between two states, open and closed. I created animations for each state using Unity's animator, and when the lead cart enters the trigger zone, the door transitions to the open state, and once the cart exits, it reverts to the closed state. Lastly, I made a script named Move Turn that manages an object's movement and rotation in any direction. This versatile script has been applied throughout the project. For instance, it controls the movement of the plane in the troposphere, the asteroids in the deep space environment, and the sea animals in the ocean environment. So that's it for today's video. If you guys enjoyed it, please consider giving the video a like and subscribing to my channel. Also, let me know in the comments what you found interesting or helpful about the video. And if there was anything you didn't enjoy, I'd like to hear about that too. I'm going to leave links to the scripts I mentioned in the video down below, so be sure to check those out. Thanks for watching and for being a part of my community. Moss out.
You would be